Nuclear reactions. Nuclear reactions produce a new nuclide, but total nucleons, total mass, and energy are conserved. They give off radioactive particles or radiation and very large amounts of energy, which is actually 1,000,000 times more energy per atom than chemical reactions. They involve protons, neutrons, and sometimes electrons, while chemical reactions only involve electrons. Radioactivity. When radionuclides decay, they undergo one or more nuclear reactions. They give off radioactive particles, they give off energy, or they become stable. Or all of those can happen. Balancing nuclear reactions. Nucleons must be conserved. Balance total nucleons on the reactant side of the equation with total nucleons on the product side of the equation. So it will be reactant nucleons equals product nucleons. Alpha decay. Spontaneous loss of an alpha particle have the approximate mass and charge of a helium nucleus, thus the symbol, which is He with a 4 up on the top and a 2 on the bottom. I will put it right here. They cannot pass through a sheet of paper, cannot travel far, and they're very ionizing. And they occur when the entropy ratio is low. The beta decay symbol is the E for electron with a 0 and then a -1 on the bottom, right here. Beta decay, a neutron in the nucleus splits, emitting a high-speed electron/beta particle and leaving behind a proton. They cannot pass through aluminum foil and thin pieces of wood, and they have a moderate ionization, and it occurs when the entropy ratio is too high. Gamma emission, that's the Greek symbol for Y. I'll put it right here. Spontaneous loss of a gamma ray, high energy radiation that usually accompanies the loss of other particles. So if gamma ray is being lost, beta ray, alpha, whatever, will probably get lost too. Can very slightly pass through several meters of concrete or centimeters of lead and is the most penetrating and least ionizing power. Lastly, transmutation. Transmutation is a nuclear reaction that changes a nuclide into a new nuclide. So the number of protons changes. Artificial transmutations are induced by colliding an accelerated particle with a nuclide, and that requires an enormous amount of energy to induce.